Now, the bad news. Let's take a look at this corrosion. This was cleaned up with a wire wheel. This is a steel component. On this side of the bench grinder is a brass wire wheel. Brass is a lot softer than steel. It's perfect for cleaning rust up. It's not especially loud, but I'm gonna polish this one a little bit. You can see the surface that it's polished, so that's how it looks like. Even aluminum, it's brass wheel is a lot softer than the aluminum, so it's not gonna gouge it or damage it, just gonna polish it like so. So the corrosion is still somewhat visible on the surface there, or the surface deterioration, but it's not gonna be ugly like that. And you can see some corrosion on it from past winters. That's normal. That amount of pitting is what one would expect. So that's how this looks like. Not too fancy, but it's okay. Now this one is more problematic here. The back side is flawless there, but the front side here has an interesting geometric feature. This sharp corner there. You can also see that the surface of the metal in front of it is torn and greatly eroded, something like that. It doesn't have a flat surface. Looks like that. This isn't a deal breaker for the bracket. This can be used. I'm gonna file this spur down. However, I want to point it out that this surface here, from which the anodizing is gone, had this point here as the original height. This little bit of metal here wasn't displaced because it was hit somewhere. There is no evidence of any kind of hitting on this ever. This surface here wore down. If you look at it in this direction, this was the original surface height, and now it's dished out here greatly. What dished it out is, of course, the pedal, or the brake pedal, like so, as it was rotating here. So on the other side of the brake pedal you can see the same type of wear kind of matching it. That's bad, but it doesn't compromise the pedal's structural integrity much, because most of the force is exerted this way, up and down, and a little bit of play sideways and a little bit of wear sideways is not a deal breaker, but it's a severe wear, and an eye should be kept on it. Better yet, I'll try to find a big brass washer to isolate, so that it's not to isolate the two components, so it's not soft aluminum rubbing on soft aluminum. This is a design issue that should have been addressed by Kawasaki. It's fairly easy to work around it fairly inexpensively. The same gouging is visible on the outer surface here, only about a quarter of the circle here, because the travel is only this much on the pedal, so only that much is gouged out from the pedal's edge there. So the reason for this gouging is this ridiculous fit here. This pedal isn't fitting any tighter than this on this foot peg bracket. So at this point I'm wondering, am I missing a component here that was supposed to be assembled differently, or what happened here? So I hope that makes sense, that this sideways play allows the brake pedal to rotate this way when you apply force on it, and it will start digging in there into somewhere there, that surface there on this foot peg. So it's a bad design. I'll try to come up with a sleeve that fits on this one to minimize this sideways wobble, because this is ridiculous. Small pin was also cleaned together with this spring, so no issues on this one, but corrosion and wear is evident, but no gouging, no deep gouging. So this can go back. Spring is good. I just cleaned the hook on a wire wheel, very straightforward. So I'll try to kinda improve this design and come up with something that works a little better than the existing one, because this is gonna be problematic. So this washer is what I came up with. I enlarged a hole in it by hand filing, and I made a flat side on it. Everything is rounded and no burrs, no sharp edges anymore. I couldn't find a sleeve that kind of fitted on the outside of the foot peg but on the inside of the brake pedal, and so I thought maybe two of these washers will kind of hold the brake pedal on the left and on the right, stopping it from doing this. So problem with the two washer concept is that two of these are too thick, and I don't want to take away much from the thickness of that surface there that needs to mount the pedal properly. So I'm gonna go with one washer, just like so. This flat part, this flat part will seat somewhere there, like so, and it's gonna work to some degree, stopping this pedal from rotating sideways too much. So it's still gonna be aluminum on aluminum contact on this side. That's the best I can do for now. And of course this bracket is replaceable, the pedal is replaceable, everything can be replaced, the whole motorcycle can be replaced, but I'm trying to make it as cheap as possible. There, so something like that would be the finished look, with that flat side rotated that way, something like that. So, and then for braking it goes down, up and down like so. Yeah, because the washer isn't big enough to lay flat on this side. You can see those ridges kind of hold it in the air. This circle here must be the outside diameter of the washer, and I couldn't find one with an inside diameter of this size. Well, this was actually hand filed, you can see that, and I put it around this, that it's not perfectly cylindrical. How do I do this? There, you can see that it's there, that it's a hand filed product. But so I'll try this version with grease and everything and see how this works out. I'm ready to do a test fit here with the greased up components. Actually, this is the spot where it was taken apart. It didn't need to be put in a vise. This is a deck made of wood, soft wood, and the bracket was just rested on it and the wrench was turned, and that was it. So it didn't need a vise. I want to point out a couple of fitting things here. The spring is gonna go here, and you can see it's also gouged out there because of the spring, or where the spring is seated. So that's to be expected. Normal there, normal wear and tear. Yeah, nothing lasts forever. So steel rubbing against aluminum, not a whole lot anyone can do about. The depth of this keyway here, or this flattened portion, when these two components are together, is such that about a millimeter, that not much of the shoulder is still showing, and that's for full seating. So that's why I only did one washer, because if I had two, then that's one too many. The in this position here, you can see the shoulder of the flat shoulder showing, because it's covered up by the thickness of the washer. But without the washer, you can see that well, it doesn't matter much if I add the brake lever back on, or this brake pedal back on. You can see that the gap there between these two, the bracket and the pedal, allows really only just one washer to be placed into the gap, and that's gonna be on the outside there, and over here aluminum will run on aluminum. I can't have two washers, so I'm gonna test the assembly this way, and we'll show you how this spring goes on. The test fit is going well. I discovered right away something: the pedal doesn't move because this washer is too thick. This bolt is clamping everything together too tight. So very straightforward. Pull out the bolt, take out the washer. I'm gonna have to make this washer thinner by lapping it on a float glass and some abrasive material. Custom fitting. And after a few hours of hand sanding and power sanding, we have a finished product that looks like this, and it has a thickness of 1.3 millimeters or so. Yeah, no part of it there, 127, no part of it is really thicker than 1.35 there. Okay, so this seems to work. This is close enough for the gappage here. Alright, so assembly. Let me just get a little closer. Fairly straightforward, but this is your brakes. It's a critical component. And then this flat portion there, that keyway, should match the keyway in this bracket here, which is at my thumb, that flattened portion there. So these are together, and then this is a test fit, so I'm not applying thread lock. Yeah, this test fit should work. So this is how you also tighten this for your final assembly. And when it's tight like this, then it's just a little bit out here, so it's almost good. Let me just go back and loosen it, because they only work when they are rotated into their correct position there. And for tightening, you can tighten this thing on a bench like this. Just put it down and tighten it like so. When this is tightened, the pedal should still freely move, but it doesn't have a whole lot of degree of motion. This hook is going to hit the underside of the bracket after a while, such as at around this point, and that's fine. And also the top here, let me just show you this, maybe, this one. Okay, you see this is a raised surface starting at this point, and this is a raised surface here, and this is a lower part, that's the factory original part, okay, or height. So it should work like so, but eventually this part is going to hit that corner, okay, there. So your brake lever is not going to rotate, or what, brake pedal is not going to rotate further down than this, and is not going to rotate higher up than this. It's maybe 45 degrees maximum, okay. That's enough for braking. So it's not gonna turn around 360 with this washer if the washer is the correct thickness and it's fitted properly. It's just gonna move this much, 45 degrees or so. That's all you need. From hook to bracket contact to pedal shoulder to bracket corner maximum. It needs to move just this much for braking basically, okay. And even when it's tighten to the specifications, which I'm just gonna eyeball. This is a prototype there, okay. This is tight there. This should still be freely moving, and this washer keeps the brake pedal perpendicular to the foot peg, so it's not rotating sideways like previously this way. Okay, so that's how this fit looks like. Don't force it any more than it should. So this is it. 1.3 mil thickness or 1.25. So this is how the fitted spring looks like. A couple of notes about this fabricated 1.3 millimeter washer here. So it stops the pedal from rotating sideways, and that's fine. Now this steel washer, stainless steel is fairly soft, but it's still harder than the aluminum, but softer than the weld over here on the steel bracket for the foot peg. So, and there's also somewhat forcing now, aluminum to aluminum, but forcing them, and that force is spread out over the entire circular area wherever they still contact with each other, because there's a gap there where so much of the material wore away. So that's how it should look like in normal operation. And this motion here, producing motion at the brake piston, squeezing the brake pads together, stopping the vehicle. So that's good to go back on the motorcycle. 20 seconds from here on.